in last video we solved some questions related to refractive index, and before that we had discussed about the refractive index. In this video we are going to discuss refractive index in a little bit more detail, which will be helpful in solving the questions if you are getting in the exam. So let us discuss the refractive index from very beginning. Refractive index, sometimes written as Ri, and it's a ratio of speed of light in medium 1 to the speed of light in medium 2. So ratio of speed of light in medium 1 to speed of light in medium 2 is refractive index, Ri. So what is medium 1 and medium 2? Let me draw a diagram here, and I will try to draw a glass slab. So imagine this is a glass slab. Ray of light is traveling initially in air and it enters in glass slab. So as you know, glass slab is optically denser compared to air. Ray of light bends towards the normal. I'm not going to discuss those details, but here the speed of light we are taking as v1, and speed of light in glass we are taking as v2. v1 is speed of light in air. This v2 is speed of light in glass. So as per the definition, if we want to write, we can write n, which is refractive index, is equal to v1 by v2. This is our formula, and in last video we solved some questions related to refractive index. Now we know light is a form of wave. Light is a wave, and what type of wave it is? It's a transverse wave and electromagnetic wave, right? Nature is transverse and it's an electromagnetic wave, and all the waves, they have speed, they have wavelength, which is lambda, and they have frequency, which is f. And there is a formula which relates speed, wavelength and frequency, and that formula is v is equal to f frequency into lambda wavelength. Let me create some space because I want to write here on the new slide the more details. So from last slide, which you can see here, we know that n is equal to v1 by v2, and speed v is equal to f lambda. I'm continuing on the next slide. So here we can write v1, which is speed of light in medium 1, is equal to f into lambda 1. Why I'm writing f into lambda 1, not as f1 into lambda 1? There is a reason behind that. The reason is I'm not writing f1, and let me rub it before it creates confusion. So here I'm removing this part and I'm just writing f1. So why we are writing v1 is equal to f lambda 1? Because when a ray of light enters from one medium to another medium, one medium to another medium, its speed changes depending on the density of medium. Okay, its speed changes, wavelength changes, but frequency remains same. It means the frequency of wave does not change with change in medium. So we can write V1 is equal to F lambda 1, and the speed in second medium V2 could also be written as F into lambda 2. So F here and F here are same. What things are changed? V1 lambda 1, V2 lambda 2, from one medium to another medium. So let us write the formula of refractive index once again. N is equal to, here N is refractive index, V1 by V2, and V1 is equal to F into lambda 1 and V2 is equal to F into lambda 2. So I have written here this F1 lambda 1 by F2 lambda 2. Let us cancel F and F, and we will get N is equal to lambda 1 by lambda 2. So this is one more formula to solve or to find the refractive index when light enters from one medium to another medium by using the values of wavelength. There is one more term which I would like to explain it to you, and though you may have heard about it, let me create another slide. That is absolute refractive index. Absolute refractive index. So till now you were studying about relative refractive index, though I had not mentioned about that, but it was relative refractive index. Why it was relative refractive index? Because when we took N is equal to V1 by V2, so here medium 1, in which the speed was V1, could have been anything. So this is speed in medium 1 and this is speed in medium 2. Let me write it, then I'll explain. So medium 1 can be anything. It could be air, it could be vacuum, it could be water, or anything. Similarly, medium 2 also can be anything: air, water, vacuum, or oil, etc. So what we were doing, actually we were taking the relative refractive index. Let's say if it is air to water or air to oil, it's a refractive index of, and let me write here first. So let's say this N represents N water. N what refract here N represents, N is equal to, I'm taking, sorry, apologies, N is equal to VW divided by VG. Here G for glass. So this formula, which is N is equal to VW by VG, represents refractive index of glass with respect to water. It means this is a relative refractive index. Refractive index of glass with respect to water. And similarly, we can write N is equal to Vg by Vw. It means this will represent refractive index of water with respect to glass. So here glass is the first medium and water is second medium. Now there is a term which is called as absolute refractive index. Here on the top I have written absolute refractive index. So what is absolute refractive index? Absolute refractive index is refractive index of second medium when the first medium is vacuum. So here we can write N is equal to V1 by V2, and in place of V1 the speed of light in vacuum is given by C, which is 3 into 10 power 8 meters per second. So we can write in place of V1 C by V2. And now we don't have V1, so no need to put V2. We can put here C by V. So C by V is absolute refractive index. And you can write it like this. Simple formula. So do remember that C is speed of light, and I had used this N is equal to C by V to solve the equation in last video. You can go back and check that question number 2.